Solve the system by graphing. 4x plus 4y equals 28. 4x plus 2y equals 20. Okay, what we're being given here is a system of linear equations. And the concept of a system of equations, the concept of a solution graphically would be one of these equations would graph as a line, linear system, because the exponents on the variables are positive 1. That would graph as a line, the first equation. The second equation also, the exponents have variables have exponents of positive 1. So the second equation would also graph as a line. If the lines intersect at a point, then the point would be common to both lines and hence would be solution to both equations. So we're looking for whether the equations intersect at a point. If they do, the coordinates, the x and y ordered pair of that point would form the solution to the system, because it would make those values would make the equation be true, the first equation for the individual values, and the individual values of the x and y for the point of intersection would make the second equation true, a solution to both equations. So let's go ahead and get started. Here's what solving a system by graphing would look like. I'm going to make the first equation, I'm going to label this with equation 1, and I'm associating the color blue with it. So here's 4x plus 4y plus 4y equals 28 equals 28. Here, this is equation 1. And I'm going to make the other equation. I do these in color. We're going to make the other equation green. And we're going to label it as equation 2. So equation 2 is going to be 4x plus 2y equals 20. This is equation 2. And what we're going to do is graph these both onto the same rectangular coordinate system on this big one, this big graph and rectangular coordinate system grid. And then we're going to see if the lines intersect. And if they do, we'll identify the point of intersection and continue from there. Okay, we're allowed to graph both of these equations using any method that we want. I see that they're both written in standard form, both of these equations. We're beginning with this first one, ax plus by equals c. And I notice that when c, this 28, is a multiple of a and b, I'm going to graph by intercepts. I'm going to graph this line by intercepts because I'm not going to get any fractions. And graphing by intercepts, not getting fractions is really good when you're graphing, because fractions can be kind of a pain to graph compared to, integers, whole numbers, and non-fraction numbers. So graphing by intercepts means we're going to put a 0 in for x and solve for y into the equation. We're going to put a 0 in to the equation for y and solve for x. And what we're going to get is 0 comma some number associated with y for 0 for x, and we're going to get some number for x comma associated with a y for 0. And then we're going to graph those points and connect them with a line, and it'll graph the entire equation. So this point is going to be the y-intercept. This is what graphing by intercepts is. This point is going to be the y-intercept. This point is going to be the x-intercept. So let's find them. First, I'm going to take the equation 4x plus 4y equals 28. And I'm going to make room to substitute a 0 in for x plus 4y equals 28. So now here comes, I'm going to go ahead and switch to red. I'm going to put a 0 in for x. I'm going to put a 0 in for x and solve for y. Okay, 4 times 0 is 0 plus 4y equals 28. 0 plus 4y is 4y. Divide both sides by 4. Y equals 7. So here's one ordered pair. Y equals 7. 0 comma 7. Now we're going to do put the same take the same approach, and we're going to substitute now 4x. We're going to substitute this time in the equation a 0 for y. So when I say y, I'm going to leave empty parentheses, and we're going to put a 0 in this time, put a 0 in for y. This is graphing by intercepts. Replace y with 0, and now solve for x. 4 times 0, if we simplify, 4 times 0 is 0. 4x plus 0 equals 28. And then 4x plus 0 is 4x equals 28. Divide both sides by 4. And we get x equals 7. So that completes this ordered pair. Now what we can do is go and graph these 2 points right here, 0, 7 and 7, 0. 0 means not left or right at all. And notice the spacing of these grids, each mark is a unit of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So keep that in mind as we're graphing. And these are going to be approximate points, of course. So we're going to check to make sure that the solution is correct in the end by checking the intercept point. So for right now, we're just looking for an approximate location. So 0, 7, not left or right at all, up 7, 2, 4, 6, 7 is halfway between 6 and 8. There's that y-intercept. The x-intercept is going to be at 7 on the x, and then not up or down at all. 2, 4, 6, 7 is halfway between 6 and 8. There's the x-intercept for the blue equation, equation 1. And then we're going to connect these with a line. We're going to connect these with a line. Okay. Now we're going to switch over and graph the green equation. And we're going to identify, that this is also written in standard form. AX plus BY equals C. 20 is a multiple of 4 and 2, divisible by 4 and 2. We get 0. So we're going to graph equation 2 by intercepts. And I'm going to set up a small coordinate table for x and y and the ordered pairs that we would get. And we're going to, when we graph by intercepts, we put zeros in, just like that. A 0 for x, 0 for y. And we're going to develop a couple of ordered pairs, one for each intercept. Again, this guy is going to be the y-intercept, and this guy is going to be the x-intercept. So we're getting ready now for equation 2, 4x plus 2y equals 20. This time, again, we're preparing for substituting a value for x. Plus 2y equals 20. I'm going to use red for my substitution. We're putting a 0 in for x. Here comes x out, put 0 in its place. And now solve for, similar to what we did, now we're going to solve for y. 4 times 0 is 0, plus 2y equals 20. 0 plus 2y is 2y equals 20. Divide both sides by 2. And we get y equals 10. See how we're not getting fractions? There's our y-intercept for the green line. Now let's prepare to find the other intercept. And we're working on the green line. 4x plus 2y equals 20. This time I'm getting y ready for substitution. 4x plus 2y equals 20. And we're going to substitute y with 0. We're going to put 0 in for y this time. Put 0 in for y. And solve for x, similar to what we did in the blue equation. 2 times 0 is 0. 4x plus 0 equals 20. 4x plus 0 is 4x equals 20. And divide both sides by 4. X equals 5. X equals 5. So we can use these two intercepts now to graph the green line. So here's 0, 10. 0, 10 for the green line. 0 means for x, don't move left or right at all, go up 10. 2, 4, 6, 8, 10. There's the y-intercept for the green equation, equation 2. Then, for the x-intercept, right 5, not up or down at all. Right 5. 2, 4, halfway between 4 and 6, I find 5. And we're going to connect these points. Connect these points with a line. And that wasn't a real good shot. Let me see if I can do a better. This is in a digitized world. I'm going to redraw a line through those points. And this is part of why graphing is not the best method. This is just an example to help identify how you would do it with graphing. Okay. So what we're trying to shoot for now is we're going to estimate what the intersection point is for these for this line. Okay. Now what I'm seeing here is if we were to look at the intersection point, I'm estimating it here. I don't know if it's going to be right, but it looks like the green and the blue lines intersect at this point. And we're going to approximate what ordered pair goes with that point. Let's approximate. I don't know. I'm going to draw. In other words, I'm looking for what would the x and y values be for this point. And what we do is we look for those graphically. X would be, it looks like x may be 3. I don't know. That looks like it's about halfway between 2 and 4. It looks to me like x is 3. Could be. I don't know. We're going to check. Okay, then it looks to me as though the y coordinate, if we draw a line over to the y-axis from this point, it looks as though y, let's see, 2, 4, it looks as though the y value for this ordered pair would be 4. So this is a question. Could 3, 4, the ordered pair 3, 4, be a solution to both equations? Okay, the ultimate test is we have to, it's not a choice, we have to go back to the original equations and see if substituting this point into those equations would be true. Okay, would make a true statement out of the equation. So here's substitute. We're going to substitute the point. I'm going to be very specific with this so we see where all the parts of this are coming from. We're going to substitute 3, 4, which represents an x and a y value. We're going to substitute those into equation 1 and simplify, see if we get a true or false. Okay, so equation 1 is 4x plus 4y equals 28. I'm getting ready for substitution of our x and y values. 4x plus 4y equals 28. And the substitution of our x and y values is x equals 3, x with 3, and y with 4. Question, I don't know. Once we simplify, are we going to get a true or a false? I don't know. So let's see. 4 times 3. Multiply before add. We're always doing order of operations correctly. Multiply before add. Now we add 12 plus 16, and what do we get? 28 on the left side. And when I bring down the right side and the equal sign, what we ask is, does 28 equal itself? Yes. Any number equals itself. That's true. So what this means is that 3, 4, therefore, 3 dots. Therefore, the point 3, 4 is a solution for equation 1. For equation 1. Now, is it a solution for equation 2? So now what we're going to do is we're going to replicate this checking step. We're going to substitute now our red point. We're going to substitute 3, 4, which is an x and a y value, into equation 2, our green equation. Our green equation is 4x plus 2y equals 20. Get this equation ready with parentheses for the coordinates of our potential solution. We call this potential solution, this ordered pair. Until we're done checking, we'll replace x with 3 and y with 4. And we put a question mark over the equal sign. I don't know if this is going to turn out true or not. So we're going to continue now with order of operations. 4 times 3 is 12. 2 times 4 is 8. Now we add order of operations. 12 plus 8 is 20. And we bring down the equal sign, the question mark over the equal sign on the right side, and we ask ourselves, is it true that 20 equals itself? Yes, that's true. So that means, therefore, that the ordered pair 3, 4 is a solution. It's also a solution for equation 2. That means this point actually does lie on both lines. And so therefore, in the long run, big picture, 3, 4, the ordered pair 3, 4 lies, since it lies on both lines and it makes both equations be true, then it's a solution for the entire system, the entire linear system that we were given. And I hope this helped understand what we're doing here. We go up to these choices. The first thing I see between A, B, and C and D is they're showing us an ordered pair inside of a solution set. And immediately I see answer A is showing that same thing. And when we zoom in closely, we find, when we look at this very closely, we see an intersection point that has the ordered pair 3, 4. So none of these others show that information. We're comfortable now, completely comfortable, to select answer choice A as the answer to this problem.